So in today's video we will discuss about Bernoulli random variable, right? So what is Bernoulli random variable? Bernoulli random variable is a random variable which has only two outcomes. Either x is equal to 0, that is failure, and the probability of failure is q, or either x is equal to 1, that is success, and probability of being successful is p, right? Now if n is equal to 1, then p of n is equal to p, and n is equal to 0, then p of n is equal to q. Now mean, what is mean? Mean is summation of x, right, p of x. So it will be 0 into q plus 1 into p, that is p, and e of x square, that will be summation of x square px, that will be also 0 square q plus 1 square p, which is p, right? Now variance is ex square minus mu square, which will give, right, which will give p minus p square, that is pq, right? Now we will discuss about binomial distribution. Suppose there are n independent Bernoulli trials, right, and each with same probability p of success, and x is total number of success, right? X is total number of success, right? So p of x will be what? This will be combination of n and x number of trials and total number of success, and this multiplied by p to the power x, which is probability of x success, and q to the power n minus x, this is probability of remaining failures, like where x is 0, x is 0, 1, 2 and so on, right? And then this is number of ways to arrange success in n trials, right? Now if x1, x2, x3 are in independent Bernoulli trial, right? If x1, x2 up to xn are n in independent Bernoulli trials, then e of x1 plus x2 up to xn will be e of x1 plus e of x2 up to e of xn, right? And that will be, this is n times p n times, so it will be np, right? And v will be v of x1 up to xn will be v of x1 plus v of xn, and that will be pq n times, that is npq, right? Now what is hypergeometric distribution? So hypergeometric distribution is used when sampling is done without replacement of a finite population. For example, blind balls from a bag without putting them back, right? Suppose there are n number of objects, right, and suppose there are n number of total objects, right, and there is m which is type 1, suppose it is defective, right, and then n minus 1 which is type 2 non-defective, right, and there are a small n objects drawn, right, of a small n objects drawn, and x is type 1 objects drawn, right, x is type 1 objects drawn, right? So what is the thing? There are n number of total objects, m number of type 1 defective, n minus 1 is non-defective and small is in objects drawn and x is type 1 objects drawn, right? So the formula will be accordingly P of x is equal to x will be C combination of m comma x into combination of n minus n minus x divided by combination of capital N and small n, right? Where maximum, right, where maximum is n plus capital M minus capital N up to capital M comma small n, right? Now what is C m comma x, right? So C combination of capital N and a small x number of ways to pick x defective items from capital M, that is type 1 defective objects, and what is combination of n minus capital M and small n minus small x is ways to pick the rest elements, right? And this is total number of ways to pick a small n objects from capital N objects, right? So I am arranging this. Let's move on the next topic. Now let's discuss about conditional probability connection, right? So it was discussed earlier that probability of A given B is equal to, it is probability of A intersection B divided by probability of B, right? So what I can write probability of A intersection B is equal to probability of A given B, right, into probability of event B, or I can write probability of B given A into probability of A, right? Now suppose, for example, a bag has 5 balls, 3 white, 2 black, right? And I have to draw 2 balls without replacement, right? Suppose I have 5 balls and 3 white, 2 black, and I have to draw 2 balls without replacement. So what I will do? Suppose A is first ball white and B is second ball white. So probability of both ball white will be probability of getting A, right, first ball white, and this multiplied by probability of getting second ball white given that first ball is already white, right? So it will be what? 2 by 5 into 2 by 4, right? Sorry, 3 by 5 into 2 by 4, right? And then we will discuss about geometric distribution is also called negative binomial distribution because it answers how many trial until the first success is received, right? And then we will discuss about, suppose this is given as probability random variable x and this is given as q to the power n minus 1 into p. So I can write this as 1 minus p to the power n minus 1 into p, right? So if there are n minus 1 failures in a row, then one success in binomial, n is fixed. In geometric, n is not fixed. So we keep going until we succeed, right? So generalized rth success will be given as, it will be given as probability combination of n minus 1 failures and r minus 1, right? R minus 1 events, right, into probability of getting successful into probability of getting failure, right? Where n is r plus 1 and so on, right? So this is for rth success, right? Suppose there are n minus 1 failures, then one success is given as, rth success is given as this, right? Now we will discuss about MGF, moment generating function. So it encodes all information about the distribution. Once you have MGF, you will find mean and variance by differentiating. Suppose I have g of t given as e, right, e to the power tx, which is equal to summation of, right, e to the power tx px, right? So if I differentiate it, that is g dash 0, so it will be my mean, right? And then if I double differentiate it, it will give me ex square, right? And sigma square will be g double dash minus g dash square, right? Suppose I have this given as summation e to the power, right? So I can accordingly find the variance, right? Now MGF of binomial distribution. So suppose g of t is given as p e to the power t plus q to the power n, right? And this will be written as e to the power tx combination of n comma x, p to the power x, q to the power n minus x, and this will be written as, p e to the power t whole to the power x, right, combination of n comma x and q to the power n minus x, right, summation, this will be written as p e to the power t plus q to the power n, this thing, right? Now to find g dash 0, what I will do, this is g dash t will be my n p e to the power t plus q n minus 1 p e to the power t, right? And then if I put 0 here, then I will be getting here, it will be 1, so I will get np, right? Now let me erase this. We will now discuss about MGF of Poisson distribution. Yes, so I have erased this. So we will discuss about MGF of Poisson distribution. Suppose I have g of t given as e to the power mu and then e to the power t minus mu, this is equal to e to the power mu t minus e to the power t minus 1, and p of x is given as e to the power minus mu, and this multiplied by mu to the power mu, and this divided by x factorial, right? Sorry, this is x, mu to the power x, where mu is 0, 1, 2, right? So g dash will be given as mu e to the power 0 into e to the power mu 1 minus mu, that is mu, and g double dash will be given as mu plus mu square. For this is for Poisson distribution, right? So this is all for this video. We will discuss next topic in next video.